Good day, dear colleagues. Let us present our work, the system of automated diabetes control. Diabetes is a disease characterized by high blood glucose level over a prolonged period of time. Patients with diabetes have pancreas malfunction in combination with low insulin sensitivity. This leads to fluctuations in blood glucose levels, in particular to the appearance of both hyperglycemia, high glucose concentration, and hypoglycemia, low glucose concentration. Therefore, there is a need to find treatments that can improve the living standards of people with this disease. According to the IDF Diabetes Atlas, the global prevalence of diabetes in 2021 is estimated at 10.5%, 536.6 million people, and may increase to 12.2%, 783.2 million people in 2045. The main purpose of our research is to analyze the problem of diabetes and to develop an automated control system. The defined purpose determines the following tasks: to define the basic metrics and ways of their reception for the development of the mathematical module of the system, to design the structural components and algorithm of the system, to develop an automated disease control application. To develop a system of automated control of diabetes, it is necessary to define and implement methods for collecting input data on the patient's condition in real time. This data can be divided into two groups: streaming and constant. Streaming data require regular input and include blood glucose, alcohol, carbohydrates, weight, insulin, time and date, place of administration, physical activity, stress and illness. The constant data include such indicators as age, gender, type of diabetes. For developing the mathematical module of the system, metrics and methods for obtaining them were determined. The model of the oral glucose tolerance test, or GTT, developed by Bewley in 1961. The model of the intravenous glucose tolerance test, IGTT, by Bergman Cabelli in 1979. The experimental determination of glycemic characteristics of insulin is as follows. Knowing the initial level of glucose in the blood as well as its integral characteristics, it is possible to choose the right amount of insulin. For developing, we use such tools as AngularJS and Ionic, client frameworks for building UI-oriented cross-platform mobile and progressive web applications, Apache Cordova, open source mobile development framework, Firebase for building backend logic, hosting of database, and authentication. The algorithm of the automated diabetes control system is presented in figure. First, the user gets to the authorization screen. If he is registered, he can immediately pass it and get to the main screen. Otherwise, it is necessary to go through the registration process by filling out a standard form. The entered data are checked for validity and entered into the appropriate collection in the database. Once on the home screen, the user can immediately view the statistics. The user can also go to the screen with analytics, where the information for a specified period is displayed. To work with entries, the diary screen with the functions of viewing, adding, deleting and editing entries is available. It is possible to set user settings, medication and glucose level. The data entered by the user when making changes to the settings or when working with diary entries are entered into the database. On the main screen, it is possible to add a new diary entry by clicking on the correspondent button. On the open model window with the form, current time and date are passed. After the user enters the data, validation and synchronization with the database are performed, and the user is redirected to the home screen, and methods are called to update the statistics based on the entered data. After starting the automated diabetes control system, the login screen is shown where the user must log in or register by clicking on the registration button. After successful authentication, the main screen is displayed with statistics of the main indicators for the week and for the current day, namely bolus insulin per day, the amount of active bolus insulin at the moment, the number of hyperglycemia for the current day, average sugar level in 7 days, mean deviation of sugar in 7 days, and the amount of hyperglycemia in 7 days in percent. By clicking on these indicators, the user can get reference information. On the main screen, there is a button to create a new diary entry. By clicking on it, a modal window with a form is opened. Navigation is carried out through 4 tabs: Home screen, Diary, Analytics, Settings. On the screen of a diary, all entries sorted and grouped by date and time are displayed as rows of cards with entered matrix. By clicking on any entry, a modal window is opened to edit or delete the entry. This window has a form with all the necessary fields for filling: medicine, food, activity, sugar level. The user can also choose the time and date of the entry. In editing mode of an entry, a button for deleting an entry appears in the navigation bar with a dialog box to confirm the deletion of the record. On the screen of Analytics, the user can choose the desired period of a report, namely 1 day, 7 days, and 30 days. Also, the date can be specified from which the data will be calculated. The screen with settings displays the user's email and the list of setting groups: personal settings, glucose settings for adjusting glucose levels for hyperglycemia, medication settings for choosing medications. There is also a login button in the navigation bar. As a result of the research, an analysis of the problem of diabetes were conducted. The basic metrics and methods of production of these metrics for the mathematical module of the system are determined. The functional requirements for the automated disease control system were analyzed. Algorithms of the system functions were defined and described. The order of interaction of classes during the execution of the programming code was determined, and the system of automated control of diabetes mellitus was developed. The software product is ready for use. Thank you for your attention, dear colleagues. We are ready to answer your questions.